Please welcome from Microsoft, Michelle Nooralli and Matt Butcher.
Oh, this works, cool. Hey, I'm Michelle, this is Matt. Thanks so much for coming to our talk.
Yeah, we realize that we have you sort of as a captive audience here because you're all here waiting for beer. And actually, that's kind of appropriate because if you looked at your schedules, you noticed that the original title for this talk was just Helm and Handbasket. But many of you probably heard Gabe talk this morning about draft, and so we decided we had to add draft into the title. So now we've got draft in a pint glass. And if you haven't been down by the booths, there are actually draft pint glasses that you can get.
So,
go ahead.
I was just going to give you an introduction of who we are because we just kind of came up here and started talking about Helm immediately. So how many of y'all are familiar with the Kubernetes Helm project? Raise your hand. Oh, cool. That's good. And how many of y'all have actually used Helm? Oh, that's like a lot. OK, cool. So for those of you who aren't in the Slack channel already, Matt and I are core maintainers on the Kubernetes Helm project. Helm is a package manager for Kubernetes. If you're new to the Kubernetes and Helm space, we'll give you like an introduction to Helm. But since most of you know about Helm and have used Helm, we'll also have a lot more new things to show you today as well.
Yeah, we're both kind of type A personalities, so normally when we give presentations, we rehearse everything down to a science. Well, we decided to try something different today.
Yeah, so Matt and I have one-on-ones every week, and they're always supposed to be 30 minutes, but they end up being like an hour to an hour and a half. And it's because for the last year and a half to, I think, 2 years, we've been talking about the developer and operator experience in Kubernetes, and we've kind of been obsessed with especially the developer experience and talking about how that's grown. We both really like Kubernetes. And I think something that, so this is going to be basically a one-on-one between me and Matt and all of you for today. But Matt always brings up this concept that really clicks for me. And he always talks about Kubernetes as an operating system. So Matt, can you tell us a little bit about this Kubernetes as an operating system metaphor that you keep using, and where Helm fits in this worldview?
Yeah, sure. Yeah, and this has been something that we've talked about in the Deis group for a long time, because it really sort of resonated with us once we started talking about Kubernetes that way. It helped us sort of frame out, and you'll hear that a lot today, because we like to talk about good ways of framing things out and reducing the cognitive overhead of stuff. An operating system is an environment in which you run your applications, right? I mean, in a very, very basic and generic sort of way. And what seems to have happened is that we started out with a definition of an application that went something like this. We have a program, right, the binary that we're going to execute. And this has, the operating system provides it with all of the facilities it needs to run. So we get a file system, and we get standard in and standard out as file descriptors, and the operating system handles the allocation of memory and things like that. And we were all very comfortable with this way of thinking about programs. Well, then along comes this containerization model. And really, if you think about it, what containerization has done is changed sort of our little encapsulation. And instead of talking about the program as just the binary with its supporting file descriptors, we're starting to think about programs in terms of that little bundle, plus the wrapping file system and supporting area that the container captures, right? So in a way, Rocket and Docker and this whole containerization movement with the single process per container model has sort of changed the way that we sort of conceptualize what our application is and how we model a program. Well, if that's the case, then one way of thinking about Kubernetes is as a sort of operating system, right? A big environment that handles all of the runtime lifetime of your application. And so instead of thinking of the operating system as just Linux, we've kind of bumped it up a level. And once we start talking about Kubernetes that way, it really starts to open up a new way of thinking about the way we are developing things and actually what kinds of things we should develop. I guess in a sort of strange way, if Kubernetes is an operating system, that means that kubectl is like BusyBox. But then we start talking like that. And as we got discussing, well, what are the crucial things that make certain operating systems successful? One of the things that we hit on very early, because it hurt us, is we need a package manager, right? We looked at things out there like homebrew, like apt, like yum, and we said, well, Kubernetes needs something like this. And that's sort of where Helm was born, right? And Helm was designed with sort of the idea that we'd have a package. In Helm, it's a chart. And we would have some programs whose responsibility was to install a chart, to build a chart, to upgrade a chart, to roll it back when it fails, and so on, like that. And so that's sort of how it came out of this metaphor of the operating system.
So I'll take us through a kind of a demo of what Helm does in a second. Matt's going to set up for me. But before we go into that, so like Matt mentioned, a package in the Kubernetes space in the Helm world is called a chart. A chart has three main components. It's comprised of some metadata, which kind of talks about what the name of the chart is, a description, a version. It'll have like some keywords associated with it, email addresses if you need to complain to someone, and those kinds of things. The bulk and the meat of the chart is the templates directory. This is where the Kubernetes resource definitions live. These can be templated or non-templated. If they're templated, the config will live in a file called values.yaml. And lastly, there's documentation. So there's a few different places in the chart that you can put in documentation. The README is the first and probably the most obvious one. So
there you go. We are going to attempt 3 live demos.
Yeah, here it goes.
What could go wrong?
So I'm just going to take you through the commands that I generally use. I think that's kind of helpful. So the first one is search. So if you want to see what's in, or if you want to find Redis, right? Like let's look for Redis. Okay, cool. So there's a stable Redis chart that showed up. The Helm search command is going to search through chart repositories, which is where charts live, to find the available charts that you can install into your cluster. So let's check out what versions of this Redis chart are available. And I'm going to install an earlier version of Redis so I can do an upgrade and kind of show you what the differences look like. So if I do let's see, I think the command is search stable Redis and -list for the versions. So we have several. I'm going to take 0.5.0 and install it into my Helm, into my Kubernetes cluster. So do a Helm install, stable Redis. Also, charts are namespaced by the chart repository that they're in. So when you see stable, that's the name of the chart repository.
Yeah, so unstable ones tend to go in incubator. You can set up your own repository and put your own charts in there, organize it however it makes sense for you.
Okay, cool. So some stuff happened. Let's kind of make this a little bit smaller. Is that okay? Yes? No? Just waiting for beer? That's cool. All right. So stuff happened, which is good. So after the install command, we got a bunch of output. The first thing that we'll see is this name field. So every time you install a chart into your cluster, Helm gives you a randomly generated release name, which is the best way to learn new vocabulary words. So I have no idea what bunking sabertooth is supposed to mean. Also, Matt built the random name generator library, and I've learned so much from it.
It might be the only library I'm ever proud of writing.
Cool. So we have some metadata, like when it was last deployed, what namespace it was deployed in, and then there's a resources section. I think after the packaging format, I think the most important thing Helm does is it creates this abstraction that's kind of above your Kubernetes resources that lets you think of different Kubernetes resources as an application. They're related, they work together, and when you install them, they make up this abstraction we call an application. So these are all the resources that were defined in our chart. We have secret, we have PPC, service, deployment, and if we go back to kubectl, I try not to say kubectl out loud in public, but it happens. So, and now I've forgotten how to use kubectl. Okay. All right, so we have a Redis pod here. So it's namespaced by the release that was in. We'll just like generate a name for you, or you can generate the name of the pod based on how you template your Kubernetes resource definitions. But let's actually look a little bit further into this. We'll specifically, we're looking for like what image we're running here. So, oh, check it out. So it's bitnami/redis 328-R1. So let's remember that. And now we're just going to run a Helm upgrade on the release name, which was what, bunking Sabretooth? You can pick shorter release names if you want.
Yeah, but that's no fun.
So if I just like, in fact, let's do something a little bit different. Has anyone used the inspect command in here? Yeah? Oh, cool. So it'll be kind of new for everybody? Nice. So when I want to see what the values look like for a particular chart, but I don't want to like fetch it and untar it and all that stuff, I'll just use the inspect command. And so if I inspect what stable Redis looks like at version 0.6.0, which was the latest one, then I'll see some stuff. And see the image is Oliver. Oh, okay, that's not the one I wanted.
Yeah, so basically that command will show you all the different things you could configure in that chart, the Helm Inspect command. So it's a great way of kind of taking a look at a chart and saying, oh, okay, that's one of the things I want to configure. Or this chart doesn't allow me to configure this. I'd have to actually edit the chart or something like that.
Okay, so that's not the image I was expecting, but it's a different image. So let's just run an upgrade and see what happens.
What could go wrong?
Cool.
Random
So
chart.
we'll do Helm upgrade on bunking Sabretooth. Right, we need a chart to pass in. So we're upgrading our existing release to a different chart version. And we got the same output, or similar output. And do get pods, and we see we're creating this guy. Or girl.
I like plundering dolphin. That was another good name.
Oh, yeah.
I don't know how you plunder without having arms.
So this image changed to 3.2.9. It was 3.2.8 before. So this is just to show you that, and many of you are already familiar with Helm. This is just to show you the basic workflow. You can install something. You can upgrade a set of resources that are related, and you can also delete them. So if I do delete, it should delete all of the resources that were associated to my release, which was, a release is an installation of a chart. So we'll go back to kubectl, since I've already said that out loud. And you see that the pod is terminating. Okay, so that's a basic idea of what Helm is all about.
Yeah, and hopefully it sounds sort of unremarkable, right? Because it should feel like a package manager. It should feel very similar to like apt-get or yum or homebrew or something like that.
Yeah.
Should we switch back over to the...
Yeah. And it's been really cool to see Helm used in the community. It's grown a lot. But we're seeing people use Helm as a pluggable, modular component that they can put in different workflows that make sense for them. Because at the end of the day, we are all snowflakes, y'all. and that's okay. And you might have to do something a little bit different. So you can just plug this thing into your existing pipeline, or you can make something else happen. And Helm is not so opinionated that you can't do that. And that's something that I really enjoy.
Well, and that's why we've been making an effort to move more toward a plugin-based model with plugins on both the client side and on Tiller, the server side, because we know that everybody's workflows are going to be unique. And we want to make it possible for people to build the extensions that are really going to meet their own needs instead of trying to build one tool that handles every possible use case that ends up, as we all know, not really satisfying anyone.
You'll see an example of one of the plugins tomorrow. I think Jimmy Zielinski and Antoine Legrand are talking about app registry, which is an awesome example of using a Helm plugin.
Yeah,
so,
really first-rate plugin.
Yeah. And the community has grown a bunch.
And yeah, it's hard to believe. I mean, we felt like we had this little idea, and we've seen so many people jump in and help, and it has been unbelievable. Because we've had over 150 people now have merged PRs into this thing. And really only about 5 to 10 of them are people that we even knew going into this project. So it's been like just lots and lots of people from lots and lots of different places contributing things everywhere from, a couple of lines of code to these gigantic feature requests and things like that. Our Slack channel, we had to break into 2 recently because we crossed the 1,500 mark, and now we're up to about 1,700, and it's just kind of a thriving, self-sustaining community. It's been great. And on Thursday mornings, we have an open public developer call where any of the core devs who can will get on this call, and then anybody is invited to join. And what has come of that is, well, several things, but among the coolest things that have come of that is it's created a good, tight feedback loop where people who are using the product can jump in and actually articulate, these are the things that I can't figure out how to do. I have some ideas about maybe how we could do them. And those things often turn into big feature requests, and we've gained several new core contributors from within this community. So it has been really fun to see the community sort of thrive and grow together, and for this project to really take on a life way beyond what we thought we would be able to build when we started this out.
Yeah, we have lots of new friends.
Yeah, that's right, yeah. And SIG apps is fairly closely related. Helm is part of the SIG apps group, so if you've been involved in SIG apps meetings, Michelle is one of the co-creators of SIG apps, and Helm often gives its updates and demos in that particular group. What morning is that? That's Monday, isn't it?
Monday mornings at 9 a.m. Pacific, and they're recorded and the meeting minutes are posted. And if you want something and you're not in the right time zone, just ping us and we'll just move the meeting for you that one day because we're really nice like that and we want you to be a part of it. So,
do I get to do another demo?
Yeah, you totally
It's my turn to do a demo.
So we've been taking a lot of feedback from the folks that are involved in the community, and we realized learning Kubernetes and then learning Helm and then learning how to template charts, if you haven't even done Go templating before, is like a lot. So Matt built this really cool thing that I'm so excited that he's going to show us, especially because I've been so skeptical of IDEs. But this is something that's really gotten me over the edge. So I'll let him.
So how many of you use VS Code or have at least kicked the tires on it a little bit? So it's kind of new to me. I'm sort of an old school Vim user. But some friends pointed me to VS Code, and I started looking at it and thinking, wow, this is great. It's really easy to write fairly sophisticated plugins. And we knew that the Helm command line was, we had worked really hard to try and make the command line fairly straightforward and keep the chart format fairly basic, but we realized that the actual process of writing a chart was actually kind of a pain because we get used to having some tooling to help us. And so I wanted to try and take a shot at building some tooling. So this is my VS Code plugin here. So what I'm going to try and do is create a new Helm chart. So we've got some built-in commands here. That first one's the one I want.
Can everyone see this? Is the text too small or anything for anybody back in the back? Oh, okay, cool.
All right, yeah. So I'm going to create a new plugin here. I'm going to call it, or a new chart, call it my chart. There we go. So now you see over here in this navigation pane, we've got our new chart. This should look familiar because it's similar to the structure that was put up on the board a couple of minutes ago. We've got the charts directory for subcharts. We've got the templates directory, the chart.yaml, and the values.yaml. Now, here's where having some assistive tools is really nice. Because when we write these templates, we end up having to write things like this. And I was working with one of the guys in the community who said, hey, do you have a minute to do some screen sharing? And I said, yeah, sure. And don't all try and ask me that question. I just realized I might be advertising that I'm screen sharing with anybody who asks me. We paired up, and we looked at this chart, and it was a huge chart, very, very sophisticated chart. And there was something wrong with it. And he said, I've been spending hours upon hours debugging this, and I can't figure out what it is. Well, when we opened up the templates, he was looking at a white background with plain black text over the top of it. And we just stared and stared, and eventually we realized it was a missing curly brace that was causing the problem, right? And I got to thinking, well, we could do better than this. So I started working on syntax highlighting, and that's how I went down this path. So we added some syntax highlighting. Then
which in and of itself is like, thank you so much.
yeah, it is nice. Now you can find the missing parentheses. Then added some kind of built-in support. So if you can see this, when we hover over Kubernetes objects, it gives us the Kubernetes documentation about those objects. If we go over into our Sprig templates and we hover over the templates, it'll give us some help text about what each of these does. And even with our variables, the chart variable, the values variable, things like that. So we should be getting closer to being able to author these charts quickly. I get autocomplete off of things now, and I can start, basically writing code much more rapidly because I've got all this help for me. Now, one of the things I realize that we do fairly often is we're writing these templates and we're looking at this stuff, right? And we see the curly braces, but we're going, all right, when I go to render this chart, what's it gonna look like, okay? And up until recently, we've been telling people, all right, you just dry run it. You send it up to the server, let the server render the charts and return it back, but don't have it do the installation. Well, that's kind of a pain because a lot of times you just wanna see this file, right? I just wanna see the deployment.yaml. And so, this turned out to be the perfect environment to add something like, hey, let's preview a template. And then it just shows me that template on the left rendered out on the right. And when I go and change stuff here, I'll change that one to all uppercase. And you can see over here, that one changed to all uppercase. If I change that back to all lowercase, and it goes back to lowercase. So this whole plugin, I've never gotten clapped for changing something to lowercase before, but thank you very much, I appreciate it. And so we tried to build a whole suite of tools. So this plugin, as it stands now, has previewing, it has linting built in, so I can run the linter that Miguel, who's sitting right over there, wrote, and do a Helm lint on this chart and have it dump out at the bottom. It ran through the linter. It didn't find any errors or warnings, but it recommended that I might want to add an icon file. Basically, all these tools are here to try and streamline the whole process of developing a chart so that it's not quite as painful. And all around, I mean, the theme here is that we wanted to make Helm feel more and more comfortable to the operator, to DevOps, to SREs who are building these charts. Because we really wanted this experience to be pleasant. We wanted it to be more quick. We wanted it to be easy to learn. We wanted it to feel kind of like home, right? And when we were talking about this earlier today, this reminded me a lot of your KubeCon talk because you were talking about the improving experience for DevOps people. You want to share a little bit about your...
Yeah, if I had time, I would do a slow clap for that demo, but since we aren't there, we'll just forgo that. Anyway, so yeah, at KubeCon, I had done a talk. We've been talking about the operator experience and how awesome Kubernetes has been for the evolution of ops. And I see the evolution of ops a lot like the evolution of the vacuum cleaner. We went from, we were hosting applications on actual physical machines, and that was really hard, especially without configuration management tools. So that was the era of the broom. Then we moved to using more mature configuration tools like Chef and Puppet for managing virtual machines on AWS and OpenStack. And things got a lot easier, right? Because you could scale and configure machines a lot without being so manual. And so that's what I call the era of the more popular vacuum cleaner as we know it today. And so in that scenario, you still have to define the steps to your end state. You still have to give it some direction, but it's much easier than any phase before. What's so exciting now, though, is that we're at this whole other level where you don't even have to worry about which application goes on which machine. We're now instead talking about things like scheduling resources, and scaling applications can be as easy as modifying the replica count in one command. And desired state is something you declare instead of an abstraction in your mind that you're trying to get to while you're banging away at keys desperately at 2 a.m. This is the era of the Roomba. And so Kubernetes has done a lot for the evolution of the operators and their experiences. I really feel for them. I empathize with them. Because frankly, developers are spoiled. we realized this when we were trying to onboard developers at Deis to Kubernetes. Right, Matt?
Oh, yeah. I mean, we probably made every Kubernetes-related mistake in the book. It actually, we realized at one point that we have, I don't know, had a couple dozen repositories, but we kept copying and pasting from each other's make files for those little segments that did things like build a Docker image, push the Docker image to the repo, pull the Docker image here. And it got sort of embarrassing because we were apparently too lazy to even write new make files and do anything better. But it was part of what was going on with us is we weren't feeling comfortable with Kubernetes yet. And then as we felt comfortable, we were just repeating tasks by copy paste and by surreptitiously sneaking little things back in everywhere instead of building something that was actually helpful to us.
Yeah, I mean, if you even check out like all of the repos in the Deis org have pretty much basically the same makefile, and then we use those for like personal usage as well. So we were just repeating everything.
Yeah, and all of that sort of underscored the fact that Kubernetes for developers is not an easy thing. There is not a clear workflow. There are not clear tools for it. And it sort of feels like the Wild West. You're sort of out on your own trying to figure out how you're going to get from your source code to that thing that's running there in your Kubernetes cluster.
And I think we kept complaining because like Matt and I, and a lot of the engineers at formerly Deis, now Microsoft, we have application development backgrounds. So we've been working with things like Ruby on Rails. And if you're a developer, you know that when you have an idea, the most important thing is to get that idea to actually exist in real life. And that whole, from your head to actual working program is like a really euphoric experience. And I come from a Ruby on Rails background, and so I just kind of have this expectation that like things will just work really cleanly, and if I have the idea, it'll exist in like 15 minutes. And that's kind of where this tagline comes from. Ruby on Rails became really popular on this promise of being able to build a blog in 15 minutes. And we realized that's something that was missing with our workflow in Kubernetes.
Right, because Rails was really kind of that Roomba experience, right?
Yeah.
And
for developers.
So the developers were already spoiled. They were already on that end. And then Kubernetes was really like trying to drag them all back and say, OK, now you have to go all the way back to the days where you know everything about every little piece of the system before you start writing your first line of code.
Yeah, like you got to know all the Kubernetes resources, resource types, what they mean, how they play together.
Docker files, Docker command line,
containers,
yeah.
All the pitfalls all of the things that we had to learn when we were getting started with Docker, which is awesome. Like containers are great and all of that, but it was
a lot harder than rake scaffold or whatever that first command was you run with Rails. Yeah.
Yeah,
I don't even remember anymore.
So you want to talk about what Gabe demoed this morning?
Yeah, so how many of you saw the keynote this morning with Gabe doing them? Yeah, so I'm going to show again. In trying to get this VS Code thing all polished up and everything, I went, well, wait a minute, we might as well do a draft commands in our VS Code extension here. So I will quickly run through creating a new application inside of VS Code with the Helm extension using draft. So, and when I say quickly, I mean quickly. So I did a draft create. We're going to name our new application hello. We are going to make a PHP application. We now have a PHP application. Now you can see I've got my chart here. I've got my values file. I've got my draft.toml file. So this is where you set up your environments. Again, very similar to Rails, where you can have a development environment, a production environment, and I can go in here and change this. I'm actually going to set the watcher to false so that we can watch the watch process go all the way through completion. OK, so I've just scaffolded out the basics that I need. I chose PHP because I can be really lazy and write index.php and write PHP echo hello. There we go. Now we have a complete, all but kind of lame, application here. And we can go do a draft up. So now when I do a draft up, It is going to take my application. It's going to scaffold it out according to the PHP setup that we declared we were going to use. It's building a Docker image. It's pushing the Docker image to my Azure Container Registry. Got my Azure plugin there. And then it's going to deploy it right into the Kubernetes environment that I have running on ACS. And so all of this is happening behind the scenes. It looks like it finished before I even finished describing what it was going to do. So now we've got this thing up there running just like what Gabe demoed this morning. And anytime we want to update it, if I had it doing its watch, it would just automatically update. I turned that off so that I could show you again here. I just do a draft up, and it kicks off yet another container build and is building the whole thing. So really what we were trying to do there is capture that same kind of quick, what did you call it, mean time to dopamine? The mean time to dopamine experience that you get with Rails and package that up for Kubernetes.
Yeah, and the idea is like, we all do the same things over and over and over again, and I think once you identify that this is the workflow, the next plausible step is to automate it, and that's kind of just what Draft is. We're really excited about it. I'm excited about it because I just don't want to keep repeating those same tasks. So if nobody else is excited about it, then just me. But who's excited about it? Are we going to use it? Okay, cool, awesome.
Now, one thing that Gabe didn't mention this morning that I actually think is one of the cooler things about Draft, and Michelle, because it's built on Helm, the process of handing it over to the operators from the developer is as simple as running your Helm package command and pushing it up into the registry, and then the Helm package itself sort of becomes the contract, right?
Right, and so it's the thing that you can throw over to the fence. It's a thing that you know is going to work reliably in different Kubernetes environments.
Yeah, and you showed that Helm Inspect command, which is great because then, so your developer can give you their Helm package and you can run Helm Inspect on it and see all the things the developer thought you might want to configure and just immediately deploy that into the cluster, configuring the things you want into production, or go back to the developer and say, hey, can you add some configuration for this kind of thing? So it was designed to make it easier to exchange. So in some ways, I guess it's like, we were talking about the broom, vacuum, Roomba thing for DevOps, and then talk about the broom, vacuum, Roomba thing for developers. But in a way, we're only successful if at the end of the day, both of them are also communicating efficiently and effectively together.
Right, and the fact that Helm can fit into this system modularly, it's like, I don't know if that's a word, in a modular way is also really cool to see because Helm is the right abstraction layer for what we're doing, and then we've built this more opinionated workflow that we need for our daily tasks on top of that or around that.
Yeah, there's a lot to be said for minimally opinionated workflows,
Yeah. So, we released Draft today, and it's very young. And we had a really great experience working on Helm with the community. So we want to do the same thing with Draft. If this is something that you're interested in, please join us. It's very early. If you have ideas on how it should look and feel, please file GitHub issues. Pull requests are very much encouraged and asked for. So
yeah, we should give a shout out to Matt Fisher, who is the lead developer, and Matt Tucker, who also came along and helped. Matt Fisher is out of the country right now, and so he's missing the sort of premiere of his application. But when he gets back online,
but it's totally fine because he went to Paris and all these awesome places.
We're not feeling sorry for him.
Yeah.
So with that, the Hackfest.
Oh, yeah, and tomorrow there is a Helm Chart Hackfest at the Microsoft office, 1355 Market Street is the address. Y'all should come. All the information's online, and if you have questions about Draft or want to just get started or need some help with either Helm or Draft, we'll be there. We're happy to get you started and set up and all of that. And we're really nice, and we're happy to take any other questions that
yeah, we'll be talking about chart best practices, helping develop some really high quality charts. The charts maintaining team, charts maintainer team, a whole bunch of them will be there. And then, yeah, we'll hack on Draft as well. So it'll be fun. I'm looking forward to it.
We're excited about it.
Yep. So I know we're getting dangerously close to beer time, but we have a couple minutes. If anybody has some questions they want to ask or open up the conversation and talk about related stuff, we'd be happy. Do we have a cool, awesome.
So fancy. Usually it's me with the mic going up to people.
So I wonder if you could just talk a little bit about curation. So in the package management world, we see a huge range of curation of packages, ranging from maybe Wild West of CPAN up to this is the one true way to deploy, to package up something. I'm wondering if you could just talk about the Kubernetes philosophies behind how you're curating the charts that get put into the incubator and stable.
Would you mind passing the mic up 2 people to Sean in the second row? So Sean is one of the maintainers of the official Kubernetes Charts repository, and he was close enough to you that we can get away with putting him on the spot for this.
This is so
Do you want to answer that?
Yeah. So one of the kind of core principles we have with charts is to solve for the 90% use case, cloud native applications, the patterns. What are the patterns here that are useful? Not every single configuration option. So it's a real thin line to tread, but you see this a lot in the charts repo. Some of the bigger charts, say like a Prometheus chart, has so many possible permutations on how a team might want to run it. So we just have to tread that line with what shows the best capabilities of Kubernetes, cloud native applications in general. And that's still something we actually need some help with, and we need a harder line to draw. But that's generally how we approach it.
Yeah, I do think the ecosystem's been so new that we've actually learned a lot of lessons as we've gone through it and are still learning lessons.
Great talk, thank you. I'm curious what compute resources would be required to run, the new tool locally on a laptop, right? So instead of the tool up.
Draft, yeah.
Thank you, Draft. Draft up, and that sends it to a Kubernetes cluster, potentially in the cloud or whatever. I'm wondering if we could, the same workflow we could run against a mini-kube instance, right? So I'm less tied to network access. I have a team of developers that have bad network access, and so that would introduce a lot of latency to depend on this sort of supercomputer that we're submitting jobs to, right?
Yeah. Do you want to answer or you want me to?
You got an all.
Okay. Yeah, so I believe that the core developers who started on Draft all began on Minikube, figuring that was probably the most likely development scenario. And I know different, my opinion is I would like to see more development go into the cloud. So when I demo, I do stuff like this. But you know, Matt Fisher, who's in Paris right now, would say, well, no, actually, I prefer doing all my development on my workstation because network latency is the throttling factor for me.
I also use Draft on Minikube. That's my preference.
And so essentially, if you can run a Kubernetes cluster locally and run the Docker daemon locally, you should have sufficient resources for your basic charts. And then, of course, the more complicated your Draft application gets, you know, if you're running a massive Java application that's going to require gigs and gigs of RAM, your box will obviously have to suit. But that seems like a fairly stable metric that you can compute with, right? Yeah, for me doing the cloud-based one, I just spin up the basic Azure ACS cluster, which is, I think, a 3-node cluster, and that's sufficient for me, but we haven't done a whole lot of that on teams. I'd actually be curious to hear if anybody does development with teams all sharing a cluster together, how they've noticed resources scaling on that side. How's that? Does that answer your question, or? Okay. Looks like we are down to the wire. Do we have any more?
He has a question, but we're waiting for the mic.
Where's that?
Up front.
Yeah, just back to Helm, how does it deal with variations in the underlying cloud provider? Is that done via templating? So if I want to deploy a package to Azure versus Amazon, can I template that out in the chart itself or something, those variances?
It should be the same.
But maybe I'm using a different load resource or load balancer, or how do I deal with those variances?
Yeah, so as a rule of thumb, you can make your charts as complex as you would like to. And so Sean, who's sitting behind you, who is in charge of the public repo, is well aware of all the nuances when different storage backends need to be configured just slightly differently. The
Right.
template language has conditionals in it, has access to the type of Kubernetes cluster and access to the list of resources. And so if you construct your chart fairly well, then you should be able to deploy it into whatever clusters you need to support based on that chart. That's hard though, right? Because it does require some foresight and some good background knowledge. That's why those stable charts and the stuff that's in the official Kubernetes repo, it tends to veer toward the more complex configurations when it comes to things like, what would you say? Ingress is one that gets a little tricky to configure. The persistent volume storage gets a little tricky to configure. Other things just seem to work fairly well. There isn't a whole lot of variance. When it comes to third-party resources or extensions that were done prior to the third-party resource system, like I know OpenShift has a few of those, that can get really tricky to figure out a way to make those portable. And largely the pattern that I've seen emerging is that the charts will declare the third-party resources and the operators or controllers in the chart so that you can make sure those things get deployed. So in the end, at the end of the day, the real answer is, well, it can support as much as you're willing to put into the templates as you develop the chart. So. That's it. All right. I think we are at time. I hear that there might be some beer or something somewhere. So thank you guys very much for spending the end of the afternoon with us.
Thanks.